Hi everyone, Assalamualaikum. In this video, we will discuss example 5 under homogeneous equation for first order ODE. Solve the homogeneous first order differential equation dy over dx equals to x cubed minus 2y cubed over negative x y squared. Right? From the given question here, we have x cubed, which is degree 3. Y cubed, also degree 3. And then we have denominator x to the power of 1 times y squared. This is also degree 3. So from here, we have same degree, which is degree 3. So this is a homogeneous equation with degree 3. Right? To solve homogeneous equation under first order ODE, first step, we need to write dy over dx as a subject and name as equation 1. Okay, from the given question here, we already have dy over dx as a subject. Okay, right, we have dy over dx equals to x cubed minus 2y cubed over negative xy squared. So we can name as equation 1. Right? Then we continue with step 2. Substitute dy over dx equals to x dv over dx plus v and y equals to vx into equation 1 here. Okay, so after we substitute, we get this. Right? Let me check one by one. Okay, from here, we substitute dy over dx equals to x dv over dx plus v. And we substitute y equals to vx into equation 1 here. So this is y. We replace by vx. And this is y in denominator. We also replace by vx. Right? After that, we simplify this term. Okay? So we have x dv over dx plus v equals to x cubed minus 2v cubed. And then x cubed over negative v squared. And then x times x squared equals to x cubed. So we get this. Right? Right, then we continue with step 3. Factorize and simplify x cubed. Right? From the fraction on the right hand side here, we have term containing x cubed for numerator and denominator. Right? So we can factorize it. Right? So we still have x dv over dx plus v on the left hand side. And then we factorize x cubed. So times in bracket 1 minus 2v cubed. And then over negative y squared x cubed. Right? We don't need to factorize denominator because we only have single term here. Right? Right. If we have a homogeneous equation with degree 3, we will succeed in factoring x cubed. Right? If, let's say, we have a homogeneous equation with degree 2, we will succeed in factoring x squared. So that's the pattern of homogeneous equation under first order ODE. Right? So from here, we can simplify x cubed here and x cubed in denominator here. Right? So after we simplify this, we get x dv over dx plus v equals to 1 minus 2v cubed over negative v squared. Right? After that, we can solve separable equation. Okay? We continue with step 4. Separating variables v and x. Right? We can refer BODMAS. Okay? Alright. Under BODMAS rule, before that, BODMAS is an acronym and it stands for bracket, order, division, multiplication, addition, and subtraction. Okay, if we want to solve a mathematical operation, we need to follow the order of BODMAS. But if we want to separate, we need to reverse the order, right? In this case, we want to separate. Okay, so we need to move minus or plus first, right? So from here, we have plus V. Okay, so we need to move to right hand side. So we get this. Okay, x dv over dx equals to 1 minus 2v cubed over negative v squared and then minus v. After we move plus v to right hand side. Right? From the previous slide, we get this. X dv over dx equals to 1 minus 2v cubed over negative v squared minus v. Right? So from here, we need to standardize the denominator. So we get right hand side equals to 1 minus 2v cubed minus v times negative v squared over negative v squared. Right? Then we simplify this. So we get x dv over dx equals to 1 minus 2v cubed minus times minus equals to plus, okay, positive sign here, and then v cubed over negative v squared, right? Then we can simplify again. So we get x dv over dx equals to 1 negative 2v squared plus v cubed equals to negative v cubed, right? So we get numerator equals to 1 minus v cubed over negative v squared, right? And after that, we can factorize negative, yeah? We still have x dv over dx on the left hand side equals to, we factorize negative, and then in bracket, we have v cubed minus 1. We exchange v cubed and 1 here. Okay, but we need to put negative sign. Okay, because if we expand, we will get back 1 minus v cubed. Okay, negative v cubed, negative times v cubed equals to negative v cubed. Negative times negative 1 equals to positive 1. Right? Why we factorize negative sign here? Because we want to simplify negative in numerator here and negative in denominator here. Right? So, after we simplify negative sign, we get x dv over dx equals to v cubed minus 1 over v squared. Right? Right. So, from here, we can separate variable x and variable v. Okay? So, we can move fraction v cubed minus 1 over v squared to left hand side. And when we move this fraction to left hand side, we can exchange numerator and denominator. Right? At the same time, we move over dx to right hand side. So we get time dx. And we move multiplication of x here to right hand side. So we get 1 over x. Right? We no need to move dv here because our goal is we want to write term containing v and dv on the left hand side, and on the right hand side we want to write term containing x and dx. Right? Right, then we continue with step 5. Okay? At this point, we success separating variables v and x. Right? So we continue with step 5. Integrating both sides. Right? We just put integration sign for both sides. So now we have integration of v squared over v cubed minus 1 dv equals to integration of 1 over x dx, right? From the previous slide, we get this, okay? Now, let me discuss how to integrate left-hand side first, okay? On the left-hand side, we have numerator with degree 2 and denominator with degree 3, right? From here, the degree of the top is less than the degree of the bottom and the difference is 1, right? So, in this case, we can use U substitution. And we choose U equals to denominator. And after we integrate, the answer will give ln, right? Alright, let me check our denominator, okay? Let's say if we differentiate denominator v cubed minus 1, the answer equals to 3v squared, right? And from here, to make 3v squared, we need to multiply by 3 in numerator. Okay, we can multiply using constant only. Okay, never multiply using variable. Alright, so after we multiply by 3, okay, we need to multiply back by 1 over 3. So that when we simplify 3 and 3 in denominator here, we will get back the original function, right? Right, from here, we have numerator 3v squared and denominator v cubed minus 1, okay? Now, the numerator is a derivative of denominator, right? So, the answer will give ln denominator after integration, right? So, from here, after we integrate, we still have constant 1 over 3. And then from ln denominator here, if we have numerator is a derivative of denominator, so after we integrate, we get ln denominator. So, we get this. Okay, ln v cubed minus 1, which is ln denominator, right? Alright. From left-hand side here, we integrate v squared over v cubed minus 1 dv using quick method. Okay, then we get this answer. Alright? Or we can integrate using U substitution for left-hand side function. Okay? Alright, let's say we use U substitution. Okay, so we choose U equals to v cubed minus 1. Okay, and after that, we need to differentiate U with respect to v. So we get du over dv equals to 3v squared. Then we write dv as a subject. So we get du over 3v squared. Okay, we cross multiply. Alright? Right, so integration of v squared over v cubed minus 1 dv equals to, we still have numerator v squared, and then we replace u equals to v cubed, or we replace v cubed minus 1 equals to u using this, okay? And we replace dv equals to du over 3v squared, right? And after that, we can simplify v squared in numerator and v squared in denominator. And at the same time, we move over 3 outside integration sign. So we get 1 over 3. And then integration of, after we simplify v squared, so we get 1 over u and then du. Alright? Then we can integrate with respect to u. After we integrate, no more integration symbol. Okay? And then we still have constant 1 over 3 in front here. And then when we integrate 1 over u du, the answer equals to ln modulus u plus c. Alright? And after that, we need to replace u equals to v cubed minus 1. So the answer when we integrate v squared over v cubed minus 1 dv equals to 1 over 3 ln modulus v cubed minus 1 plus c. Okay? Okay, then we can compare with this. Okay? The answers are equivalent. So to integrate left-hand side function here, we can use either quick method or u substitution. Alright? Alright, then we can integrate right-hand side. Okay? This is easy because we can use direct formula. Okay? When we integrate 1 over x dx, the answer equals to ln x plus c. Alright? It's similar to integration of 1 over u du. The answer equals to ln u. Okay? So now we integrate 1 over x dx. The answer equals to ln x. Then we put plus c at the back. Right? Right, after that, we can multiply over 3 here to right hand side. So we have ln v cubed minus 1 modulus equals to 3 ln x. And then plus 3 times c equals to 3c. 3 is constant, c also is constant. So constant times constant equals to constant. So we just put single c here. Okay, means constant because 3c or single c still constant. Alright? Right. Then we continue with step 6. Okay. We replace v equals to y over x. Okay, because from the previous slide, our y equals to vx. Okay, so when we write v as a subject, so we have v equals to y over x. Right? So the general solution is ln, we replace v equals to y over x. And then cube minus 1 modulus equals to 3 ln x plus c. Okay, this is the general solution. Okay, we don't need to find the value of c because the initial condition is not given in this question. Alright, so this is the final answer. Alright, got it? From the previous slide, after we solve the homogeneous first-order differential equation dy over dx equals to x cubed minus 2y cubed over negative xy squared, we get this answer, right? Is my answer correct or wrong maybe? We can check the answer. Is it this answer is correct or wrong? Okay, how to check this answer? Okay, right. From the final answer here, we can differentiate back. Okay, so to differentiate back this answer, we need to standardize the denominator here. Okay, so we get ln y cubed over x cubed minus 1 equals to 3 ln x plus c. Okay, then we can write ln y cubed minus x cubed times 1 equals to x cubed and then over x cubed equals to 3 ln x. Okay, then we can write ln y cubed minus x cubed and then minus ln x cubed equals to 3 ln cubed plus c. Okay, how we get this? Okay, from properties of logarithm, log a m over n equals to log a m minus log a n. Okay, since ln is also log, okay, ln means log base e. Okay, so using this formula, we can write ln, let's say our numerator now equals to m and our denominator here equals to n. So we can split to ln y cubed minus x cubed and then minus, okay, division here when we split using properties of logarithm, we get minus here and then ln x cubed, right? And then equals to 3 ln x plus c. Okay. And from here, we can differentiate implicitly with respect to x. We differentiate implicitly because we have variable y here and we cannot write y as a subject, right? Then, after we differentiate implicitly with respect to x, so we get this, right? Right, let me check one by one. Okay, when we differentiate ln y cubed minus x cubed, we get, first we get 1 over y cubed minus x cubed, and then we multiply by, differentiate the function in ln. Okay, we differentiate y cubed, we have 3y squared and then dy over dx. Okay, when we differentiate term containing y, we have dy over dx at the back, right? And then minus, we differentiate x cubed, so we have 3x squared. Okay, and then minus, now we differentiate ln x cubed, so we have 1 over x cubed. And then times, we differentiate x cubed, we have 3x squared. And then equals to, when we differentiate 3 ln x, we have constant here, so we still have constant 3 in front. Then we differentiate ln x equals to 1 over x. Okay, and then plus, differentiate any constant, the answer equals to 0. Right? At this point, we done differentiate. Right? So now we can simplify. Okay? We simplify x squared and x cubed here. Okay? So we get, we can put 3y squared dy over dx minus 3x squared in numerator here. Okay? And then over y cubed minus x cubed. And then minus, after we simplify x squared and x cubed here, so we get 3 in numerator, and then in denominator we have x to the power of 1. Okay, after we simplify x squared and x cubed. And then equals to 3 over x. Okay, and then plus 0, no need to write. Okay. Right, now we want to write dy over dx as a subject so that we can compare to the given question, right? Right, so to write dy over dx as a subject, so first we can move negative 3 over x to right hand side, so we get plus 3 over x, okay? And then we can factorize constant 3 and 3 here. So we get 3 in bracket y squared dy over dx minus x squared. Okay, and then over y cubed minus x cubed equals to, from right hand side here, we have same denominator. So we can combine the denominator. So we get 3 plus 3 over x. Okay, after that, we have 3 times y squared dy over dx minus x squared over y cubed minus x cubed equals to 3 plus 3 equals to 6, and then over x here, right? From the previous slide, we get this, and our goal is to write dy over dx as a subject, okay? So, from denominator y cubed minus x cubed here, we can move to right hand side. So we get multiply by y cubed minus x cubed. Okay, and then times 3 here, we can move to right hand side. So we get over 3 here, right? And after that, we can simplify 6 and 3 here. So we get 2 in numerator. Okay, then we can write y squared dy over dx minus x squared equals to 2 times y cubed minus x cubed over x, right? Right, and we can expand numerator on the right hand side. So we get 2y cubed minus 2x cubed, right? After that, we can move minus x squared to right hand side. So we get y squared dy over dx equals to 2y cubed minus 2x cubed over x plus x squared, right? Right, then we can standardize the denominator on the right hand side. So we get this, right? And after that, we can simplify. Minus 2x cubed plus x squared here. Sorry, minus 2x cubed plus x cubed here. So after we simplify, we get this. Okay, we get minus x cubed, right? Then we can move y squared to right hand side. So we get dy over dx equals to 2y cubed minus x cubed over x. And then y squared here. Okay. Alright, at this point, we success, right? dy over dx as a subject. Okay. So now we can compare to the given question. Okay. And when we compare, denominator here, we have negative sign. But from dy dx here, we have denominator with positive sign. Okay. Right, so how to make dy over dx exactly looks like dy over dx in the given question. Okay. From here, we can factorize negative sign. Okay. Then in bracket, we can exchange the position of 2y cubed and x cubed in numerator here. Okay. We put minus sign and then in bracket, we write x cubed and then minus 2y cubed. So that when we expand, minus x cubed, okay, negative times x cubed, we get minus x cubed, and then minus times minus equals to positive 2y cubed. We get back the function in numerator here. Okay. And then from negative sign in numerator here, we also can move down. Okay. So we get, after we move down, we get positive x cubed minus 2y cubed over negative x y squared, right? Now, when we compare, we get denominator with negative sign. Okay? Why we can move negative sign to denominator here? Okay? Right, let's say if we have negative 1 over 2. Okay? We also can write 1 over negative 2. Okay? From here, we have negative sign in numerator. From right hand side here, we have negative sign in denominator. But it is equivalent because negative over positive equals to negative. And positive over negative also equals to negative. Okay? So, negative 1 over 2 equals to 1 over negative 2, which is equals to negative 1 over 2. Alright? So that's why we can move negative sign from numerator here to denominator. Okay? But make sure the operation in between here must multiplication. Right? So from here, we also can move the bracket here. Okay? We can just eliminate the bracket. So we can write dy over dx equals to x cubed minus 2y cubed over negative x y squared. Okay? And then we compare back from the given question. Okay? Now, our dy over dx are equivalent. Right? Then we check one by one. Okay? So it means that this answer is correct. Right? So that's the way how you check the final answer. Right? Got it? We have discussed 5 examples from method 2 to solve first order ODE, which is a homogeneous equation. Right? Coming up next, we will discuss method 3 to solve first order ODE, which is a linear equation or method of integrating factor. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.